Welding cable is not designed or intended for use as an incoming electrical service for a resistance welder. Although the specified 4/0 XLane welding cable is rated for 600 amps within 100 feet, this rating is specifically for welding applications, not for continuous electrical service. Electrical service conductors must comply with the National Electrical Code, or NIC, and be listed and labeled for that purpose. Welding cable has different insulation properties and is not typically listed for permanent building wiring. Using welding cable for incoming service could create a safety hazard and violate electrical codes. The NEC specifies cable types, ampacities, and installation methods for electrical services. Firstly, determine the appropriate ampacity for the 400 amp resistance welder service, accounting for any demand factors or motor starting requirements. Secondly, consult NEC Table 310.15 B16 or its equivalent in the applicable electrical code to determine the required conductor size based on the ampacity and conductor temperature rating. Thirdly, select conductors that are listed and labeled for use as service entrance conductors such as type THHN, THWN, or XHHW. Fourthly, ensure that the conductors are installed in accordance with NEC requirements, including proper conduit, fittings, and terminations. Welding cable does not meet these requirements and should not be used for this application. Welding cables are designed for flexibility and high current carrying capacity for short durations in welding applications. Their insulation is typically not rated for the same environmental conditions or continuous duty as service entrance conductors. The NEC defines requirements for electrical service conductors based on ampacity, voltage drop, and environmental conditions. Proper conductor sizing is crucial for safety and performance. Undersized conductors can overheat, leading to insulation damage, fire hazards, and voltage drop. Oversized conductors can increase costs and may not be necessary. The NEC provides guidance on conductor ampacity based on insulation type, temperature rating, and installation method. The NEC specifies that conductors must be protected against overcurrent by circuit breakers or fuses. The overcurrent protection device must be sized to protect the conductor against overheating and damage. The size of the overcurrent protection device is determined by the ampacity of the conductor. The NEC also specifies requirements for grounding and bonding of electrical services. Grounding and bonding are essential for safety and help to prevent electrical shock hazards. The grounding electrode system must be properly installed and connected to the service equipment. Bonding conductors must be used to connect non-current carrying metal parts to the grounding system. The NEC also addresses voltage drop in electrical circuits. Excessive voltage drop can cause equipment malfunction and reduce efficiency. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and the conductor's resistance per unit length. Using welding cable for service entrance conductors would be a code violation and a potential safety hazard. Welding cable is designed for a specific purpose, which is to carry welding current from the welding machine to the workpiece. It is not designed or intended for use as service entrance conductors, which are designed to carry electrical power from the utility transformer to the building's electrical panel. Always consult the NEC and local electrical codes for specific requirements related to electrical installations. A qualified electrician should be consulted for any electrical work to ensure safety and compliance with codes. The NEC provides tables for conductor ampacity, conduit fill, and other important information. It is essential to follow these guidelines to ensure a safe and reliable electrical system. The correct type of conductor should be determined, and also the correct size of the conductor. NEC Table 310.15 B16 gives allowable ampacities of insulated conductors rated up to and including 2000 volts, 60 degrees Celsius through 90 degrees Celsius. Not more than 3 current carrying conductors in a raceway, cable, or earth directly bared, based on ambient temperature of 30 degrees Celsius. The ampacity correction should also be considered for ambient temperatures other than 30 degrees Celsius. For example, A 4/0 copper conductor with THN insulation, rated 90 degrees Celsius, has an ampacity of 230 amps. However, this ampacity must be dated if the ambient temperature is higher than 30 degrees Celsius. Also, conductor ampacity dating is required where there are more than 3 current-carrying conductors in a raceway or cable. NEC Table 310.15. C1 provides dating factors for various numbers of conductors. The dating factors reduce the allowable ampacity of the conductors to prevent overheating. The insulation rating of the conductors must also be considered. Conductors with higher temperature ratings can carry more current than conductors with low temperature ratings. However, the termination temperature ratings of the equipment must also be considered. The equipment terminals must be rated for the same temperature as the conductors, or the conductor ampacity must be derated to match the terminal temperature rating. It is important to select conductors that are suitable for the application and to install them in accordance with the NEC. Using the wrong type of conductor or installing it improperly can lead to overheating, fire, and other hazards. For a 400 amp service, it is likely that multiple sets of conductors will be required in parallel, depending on the conductor size and ampacity. When conductors are installed in parallel, they must be of the same size, material, and insulation type. They must also be terminated in the same manner. Paralleling conductors can increase the ampacity of the service and reduce voltage drop. However, it is important to follow the NEC requirements for paralleling conductors to ensure a safe and reliable installation. In addition to conductor sizing, it is important to consider the size of the service equipment, such as the main breaker and the service panel. The service equipment must be rated for the ampacity of the service. The service equipment must also be suitable for the voltage and frequency of the service. It is important to consult with a qualified electrician to determine the appropriate size and type of service equipment for the application. The NEC provides guidance on the selection of service equipment and the installation of electrical services. Following these guidelines will ensure a safe and reliable electrical system. Therefore, the welding cable is not meant to be used for a 400 amp service. There are many different types of cable that can be used, and the correct cable must be used to prevent injury, property damage, or death.